Are you sharing your screen right now, Dave?
No, actually, we're seeing the Proctor screen. You want me to share my screen?
I'll share my screen out real quick. Let me just pop up the slides and go from there. Just a second.
Sounds good.
Just 1 second. Oh my gosh, clumsy transition. Share tray. Sorry about that. Hey everybody, thanks for coming to the Global 2020 Summer Azure Data Fest. Sorry about the goofy transition. Got over 600 RSVPs, good strong attendance in all the sessions. Thanks for attending. I want to thank the proctors, speakers, and staff. Here's the event schedule if you need a link to that. Speaker slides are going to be posted after the sessions up on our download area, so you can just go ahead and download them. Also check out our YouTube channel because we're going to have all these sessions recorded and then posted up later. Upcoming events, Friday, July 31st is an AI/ML Fest. And then our next Azure Data Fest, it'll be called Azure Data and AI, and it'll be held in the later part of the fall 2020. Hey, I'm going to hand it over, though, to Dave Mariani. Will I get that pronounced right?
Mariani works fine, yes.
Oh, okay, I'm going to hand it over to you. And then is Carol Gunst with you, or is she going to present?
Carol is here, but I'll be presenting. So
okay. Well, take it away. And I've already started recording, and I'll keep an eye on the Q&A.
Awesome. You guys, you can see my screen and hear me fine, right?
Yes.
Okay, great. All right. Thanks everybody for joining us. So today we're going to be talking about OLAP directly on top of Azure Synapse and Azure Databricks. So today we're going to be hearing from myself. I'm Dave Mariani, Chief Strategy Officer and founder of AtScale. I guess my most relevant background was that I built a 24 terabyte SQL Server analysis services cube when I was at Yahoo, largest cube in the world at the time. And that's what really inspired me to start AtScale. So we'll be talking a lot about OLAP, but OLAP in modern times. Daniel Gray will also be joining us in the call. He's our VP of Sales Engineering at AtScale, and he's going to be taking us through some of the data science angle of how we use and leverage an OLAP model on top of Azure's data products. So what we're going to cover today is a little bit about what this new cloud data stack is, and where does the data warehouse, where does the data lake fit into the picture? Why do we even care about OLAP anymore? You know, it's kind of a dirty word, honestly, and because of the failures of the past. So we'll talk about why it's relevant, and then also how it's been rebirthed in the cloud. Talking about cloud OLAP for a few minutes. Then we're going to give you a really live demo and show you just what it means when you can have the benefits of an OLAP engine with its universal semantic layer, its speed of thought queries, and its rich MDX language for expressing business logic. Just what that means when it comes to BI and ML, and then we'll save a little bit of time for Q&A at the end. So what is this new cloud data stack? When you look at sort of the cloud, everything really starts with the file system. That's ADLS, of course, in Azure, S3 and Amazon, etc. So all your files end up landing there to start their journey to weave their way up to consumption and your analytics users. We still have a place for ETL engines for data prep. Usually that's targeting the data warehouse, like in Azure Synapse Analytics. We also have the abilities nowadays to be able to talk directly to the data lake and to query that with SQL query engines. And that we're talking about things like Azure Databricks, which is an excellent way of tapping into that data lake. And what's really new in this stack is the semantics and governance layer. And this is what's really important, we believe, at scale, to be able to make sure that your consumption and the way that the data is being consumed, whether it's in BI, whether it's Tableau or Power BI or Excel, whether it's any of your Jupyter notebooks or ML platforms, or even your custom applications, that they're all speaking the same language, that they're all playing by the same rules, and that the complexity of how this data is distributed in this new data stack is really hidden from those consumers. So we'll be talking a lot about that in this semantic layer coming in the next few minutes. Data catalogs and enterprise data catalogs are excellent for keeping track of these data assets, but they really are a true cataloging tool, not an enforcement engine. So, so you can't think of a data catalog as the enforcement point, but you can definitely think of it as the policy management point. But the policy execution really happens in that semantic layer. And so a good semantic layer governance engine is going to communicate well with your enterprise data catalogs so that you can keep track of your data, but also enforce access to that data at the same time. So that semantic layer. So what is a good semantic layer? And this is really where Cloud OLAP really comes in. And so first of all, let's just talk a little bit about some of the perceptions about OLAP. The perceptions are, of course, that it stopped scaling back in the 90s, where data got bigger than what we could pre-calculate. And so OLAP was really relegated to some smaller applications. When I was at Yahoo, building a 24 terabyte analysis services cube was very profitable for Yahoo. $50 million in lift in our advertising business every year just from one cube. The problem is that it took me 7 days of 24/7 processing to actually update and build that cube. So in terms of scalability, 24 terabytes is a pittance today. And we need to go way more beyond that. There's also a perception that SQL is good enough for analytics. And you know, I think that's just not true. When it comes to the fact that you need to do moving averages, you need to do semi-additive metrics, you need to do year over year for time intelligence. Those are all, you need to do multi-level metrics comparing budgets to actuals. Those are all sort of use cases that are common business use cases where you know, SQL is difficult. You can do it, but it's difficult to get it to hop through those hoops. And then there's also the perception that cloud data warehouses are fast enough, that they're fast enough on their own to deliver the kind of query speeds that business users demand. I'm going to show you some hard data here where I'm going to show you where it's just not good enough, at least not in my opinion. So so why do we even talking about OLAP? I kind of think of OLAP in these three sort of qualities, these three benefits to business users of why they actually love it. You know, we love Subsecond queries. I think we've gotten used to in this new world of not getting that anymore. And I'm telling you that business users love to be able to ask a question, another question, as soon as the first question gets delivered. Being able to do that rapid analysis is super important to be able to do discovery. The universal semantic layer is more important than ever. You know, we sort of lived through this self-service BI revolution, really kind of pioneered by Tableau, where the business could actually create their own semantics and embed it in their dashboards and their reports. Well, the result is really chaos. You know, at Yahoo, I had my Tableau users, my MicroStrategy users, my Click users, and everybody had baked in their own definition of what an ad click was, or what a page view was. The most basic metrics of the business had no consistency. So it's just not good enough to let people create their own business metrics without any kind of centralized control or management. And then finally, it's about back to that SQL's good enough. It's really not. If you need to do anything with hierarchies, which everything is a hierarchy, time is a hierarchy. Product is a hierarchy. And you need an organization as a hierarchy. You need to be able to support that kind of business and easy to understand business types of terms and terminology. So let's just first talk about our subsecond queries. So I'm going to show you some stuff here. So at scale, we actually perform a TPC-DS 10 terabytes. So the TPC-DS benchmark by the TPC, it's a standard benchmark. We do it at the 10 terabyte level, so it's quite large. And then we measure the different cloud data warehouses against that. And Azure Synapse, these are the results for Azure Synapse. What you see along the bottom is the TPCS query numbers. So that's query 2, query 7. What you see over here in the bars is the length of time it takes to render those queries on a 10 terabyte data set. And this is, you can see on average, we're dealing about 25 seconds per query. So 25 seconds per query is really not fast enough. That is not speed of thought. That is really not what business users want. Now, they may be living with that, but we can do much better than that. And Synapse is a great data warehouse. It does a great job. All the other data warehouses out there, whether that be BigQuery, whether that be Snowflake, really these numbers look exactly the same, pretty close to the same. And then things get even worse. Again, this is in seconds once you start adding load. So in this case, that last graph was with one user query. This graph is with actually 50 concurrent users. And you can see that the average query times now are dealing with 500 seconds. I mean, that is really out of the realm of possibility. So pretty quickly, you get to the point where it is not speed of thought, and that's just not good enough. So here's an example of what it looks like for at scale doing the same thing. So this is, you can see these are kind of small numbers. These are actually you can see our average query time is under 2 seconds. So you can see that if you add OLAP on top of something like a great data warehouse like Synapse, without having to move the data, so I'll be talking about that in a bit. We're talking about using Synapse to do all that delivery, but we're making and helping Synapse do better by creating aggregates in the Synapse warehouse so that we can deliver on the same TPC-DS 10 terabyte benchmark. We can deliver query speeds in under 2 seconds. And that's really the best of both worlds. You get all the power of Synapse without having to move data with all the speed that you get out of OLAP. So it is possible. It is possible with the right technology and the right technology stack. So let's talk about the universal semantic layer now. So what about the universal semantic layer? I love this definition from Wikipedia. Apologies for clipping this out, but I think it does a really great job of why we like a semantic layer. It really is it's a business representation of corporate data that helps users access data autonomously. That's really a great definition. Basically, the semantic layer is not the enemy of the business user. It's really the friend of the business user. And that the semantic layer does all the nastiness behind the scenes and behind the curtains. So whether the data is in Synapse, whether the data is in your data lake in ADLS, whether it's in Databricks, whether it's in SQL Server, whatever it is, the semantic layer can hide that complexity in that physical storage and also interject those business terms. And that's the other part of it, the common business terms. So the business can operate on the data without having to understand how it's physically stored. So, what is life without a semantic layer? Well, this is the life that we've been really dealing with for the past, I say, ever since Tableau became popular. Is that knowledge workers, the people that are actually expected to actually run the business, are now spending their time doing data prep and data wrangling. that's not their best use of time. Data scientists spend more than 60% of their time. I've seen statistics that say they spend 80% of their time on data prep. That's just crazy. And then, you know, of course, because we have all this different cognitive dissonance when it comes to different tools reporting different numbers, our managers and our managers don't even trust that data. Because they're seeing different numbers coming up at them from different reports from different systems, and there's no way to reconcile that. You know, at Yahoo, where I ran data pipelines, I had to form a data quality team of 7 individuals, 7 FTEs, just to reconcile the different reports and point out the differences. That's just completely ridiculous. So, Daniel, are you on the line, Daniel?
No, Daniel's not, Dave.
Okay, let me take you through. This is a great example of just how the absence of the semantic layer can really result in some poor choices. This is an example that Daniel ran from Kaggle. It's about a machine learning model that was built using Jupyter Notebook to figure out the survival rates of the Titanic. And what I wanted to point out to you, and sorry for the smallness and size here, is that you can see that that this particular user is bucketing and creating buckets of age ranges, and in those buckets, this user is looking for ages. The intention is between 20 and 50. Now, the actual formula is greater than 20 and less than 50. So what that means is it's really people 21 to 50. And without that, you can see here that the people 20 or younger and the people between survivors between 20 and 50, this is actually incorrect data. 27% and 64% are actually the wrong numbers. And it's the wrong numbers because that user, that data scientist, basically made a fence post error. It's very, very easy to make. Now, if they were to use a semantic layer like AtScales, what they could do instead is that they would get they would actually get those buckets pre-bucketed. They could just use those buckets in their data science notebooks, and what they would find out is that the real answer is 52% of survivors between 21 and 50. So that's an example of just a very easy mistake to make. If you don't have a semantic layer, you're apt to make and fall into those traps. So what about the business language? You know, Microsoft invented, actually I should say, Panorama Software invented MDX, and it's become a standard way of speaking OLAP. And really, what's more important than that is that it really supports the multidimensional constructs that like hierarchies and time intelligence and semi-additive metrics. So why do people need to use this? Look, it's like if you want to be able to count how many members, unique members, are coming to your website every month, that's a semi-additive metric because that's a distinct count. If you're in health insurance, they run the business by per member per month, and that's how they cost out their procedures and figure out what procedures cost. Well, that's a multi-fact metric. If you do store versus region performance, that's a multi-level metric because you may be budgeting at a regional basis, but you have actuals at a store basis. If you want to drill into and look at credit fraud, that's drill through because you need to get to the raw data. And then when it comes to period to period comparisons, this year versus last year, or dealing with retail 445 types of calendars, those were parallel periods. And that is time intelligence, and that's doable in SQL, but very difficult to do at a scalable basis. And then finally, with currency fluctuations, that's all about metrical attributes, about looking at currency tables and integrating that with your raw data. So without that ability to do those kinds of things, and again, this is back to our TPC-DS benchmark. What we looked at is for the respective queries, we looked at what we call complexity. So in the case of query TPC-DS query number 33, which is asking for monthly sales, and it's asking for monthly sales for the different channels. And those different channels are store, catalog, and web. So store sales, catalog sales, and web sales. So if you look at the query, the raw query that TPC-DS generates, this query goes on and on and on because there's a bunch of union nulls and a bunch of complex joins and logic to be able to render that result. It's 1,872 bytes of SQL. Now, if you look at a semantic layer like AtScales, you can see that it's very readable and makes a lot of sense, very easy to use in comparison. And that's all because all that multi-fact modeling has been hidden from the user. Let's look at another example. This is time calculations. So this is listing a set of counties where the percentage growth of web sales is higher than the percentage growth in store sales. So first of all, there's percentage growth. That is it's got to be a time-based metric. And in doing that, you get to see you have 1,685 bytes if you do it the TPC-DS way. Or if you do it with a semantic layer on top of that, you're talking about 761 bytes, and it's very readable. You can see the average, and you can see the average. You can see your simple where clauses to do your predicates right in line. Okay, so what are some of the ways to get this? And get this if you really want to do OLAP in modern times. There's a lot of legacy tools that have been born, and they were all born in the 90s. And I can tell you right now, they're not really suitable to do this kind of scalable analysis. And also, they typically want to take data out of the data store where it landed, and then reformat it and pre-calculate it into a different format. So we're going to talk a little bit through that for a second. So what you want to look at when you look at Cloud OLAP is, of course, you want it to work with modern data platforms like Synapse and like Databricks, which I'll show you today. You don't want to have to move your data. So you don't want to build a physical cube. If you have to move that data in order to get the speed that the users demand, then you've already lost the game, because now you have to decide what data is worthy, and you have to add complexity, which means anything that you want to do on the fly is not going to be done on the fly. It's going to require data engineering. You want to demand that you can deliver queries at least under 5 seconds, preferably under a second or less. And you want to make sure that it's independent of the query tool. So you want to have freedom to plug in anything, and not just your query tool, not just your BI tool, but your BI platform, your AI platforms, your ML platforms, and also your custom applications. So this is kind of a eye chart. So I'm not going to take you through it because I want to show you the demo real quickly. But these are sort of some of the options you have today. And look, I love SQL Server Analysis Services. I used it at Yahoo. It's why I started AtScale, because I really saw the value of OLAP, and it's the best tool out there. But when it comes to if you want a tool that you can sit directly on top of your data and do everything that an OLAP engine can do, whether it's speaking SQL or MDX, whether it's so it has no memory limits, whether you want to be able to plug and play regardless of what you want to do, whether you want to get rid of cube builds and cube updates, then there is an option. In contrast, in terms of going without OLAP and doing it yourself and creating marts, you're talking about a whole lot of manual engineering that's involved. And that's sort of the de facto way that people are doing OLAP today. They're not doing OLAP, but trying to get close to doing a semantic layer is by manually building it with a whole lot of data engineering. And we just don't think that works very well. Okay, so the way that it works, and this is going to see this in a demo, is that semantic layer is really at scale. So you're going to see today that we're going to concentrate our demo on looking at consuming using BI tools like Tableau, Excel, and Power BI. If Daniel is on, and we're going to show you how we can use a Jupyter notebook against the same semantic layer. We're going to be talking about, we're going to be using Azure Synapse today as our data warehouse. We're going to be using Azure Databricks as our data lake engine, and of course all the data is going to be on ADLS. And I'm just going to skip past this and come back down to what you're going to see today. So again, this is the results for Synapse for our 10 terabyte benchmark. And with AtScale and Synapse together, we can deliver results, raw query results for a single user 6 times faster. We can improve user query performance at concurrency levels up to 50 concurrent users 12 times faster. And actually, we've done benchmarks with 100 concurrent users, and those numbers are even more dramatic. And then we can also save on your compute costs by cutting your bill in half. We're going to have the same numbers with Databricks, the same types of numbers. I think they'll even be even more impressive than these. Stay tuned. Now, those are coming soon. If you want to see the full report on just how we can make Synapse even better, go to our website and you can download the entire report. Okay, so in today's demo, what I'm going to do is I'm going to start with my data in Synapse. I also have data in Databricks. So for today's demo, I have my fact data for my store sales in Azure Synapse in a warehouse, but I have my product table in Databricks in Delta Lake. So I'm going to show you how I'm going to do a federated query, how I'm going to join those live at real time. If Daniel joins us, we're going to show you how Daniel can actually tap into that semantic layer and actually create new features, store those new features in Azure Databricks, and then I can consume those features through AtScale. So through the AtScale layer, we'll be able to plug and play on any of the BI tools and consume against data that's in Synapse and Databricks, and also incorporate on-the-fly feature generation without having to ever do any data engineering. Okay, so let's go. So we have about 20 minutes left, so pardon for going so fast, but I want to show you as much as we can here, and I'm going to take you for a quick tour. First, a little bit of orientation. What you see here is what we call Design Center. Design Center is AtScale's semantic layer definition tool. So what you see on the screen here is you see these objects, and this is my model. I have my date dimensions, so the dimensions are in green. I got my fact tables, which we call data sets, which are in blue. And I got some degenerate dimensions, which are in gray. That means those are dimensions generated straight from the fact table. So AtScale is built for modern data platforms. So we're really good at denormalized data. We're really good at star schemas. So we don't care how your data is organized. We're going to make it fast either way. What you see over here on the right is you see what the users are going to see. Today, I'm going to be building out this internet sales cube that you see here on your left, but I'm going to be doing it on the fly. And what you see here is you see I got my dimensions, and with my dimensions, you can see I have hierarchies in those dimensions. It's good to see that again, isn't it? To see actually hierarchies, see a city roll up into a state, roll up into a country. It's also great to see metrics and have metrics like customer counts and a list price, all spelled out without having to understand where they came from. So let's go and rebuild this model. And I'm going to rebuild this model by actually defining a new, what we call virtual cube. And I'm going to call this DataFest 2020. And now I've added my virtual cube. I'm going to enter the model. So in my model, I have a blank canvas. So the way that we do this is we go to our data sources. So what's our data sources? Our data sources, you can see there's Synapse, have Azure Databricks. So how do we define these data sources? I skipped a step. Let me come back to our settings. For defining a data source in @scale, all we need to do is to create the data warehouse. And creating the data warehouse allows us to define what kinds of data warehouses we want to connect to. We can connect to lots of them. So you can see there's Azure Synapse here, and Azure Synapse has been, if I go ahead and edit that, here's what I'm talking about it here, and you can see that there's actually two instances that or two different connections to Azure Synapse. One is for using a small resource pool. So that's just a small RC, and that's what we're using for interactive queries. But then to build our aggregates, which I'll show you in a minute, we're actually using the large RC resource group. And I can do that with @scale simply by creating multiple connections, and @scale will figure out which connection to use. And you can see with Databricks, I'm doing the same thing. So all I need to do is just to specify my connection parameters to Azure Databricks like I did here. And then I'm ready to go with my projects. So let's get back into my data fest again. So by doing that, let's start with my data fest. My Azure Synapse, and I'm going to start with my sales log table, and I'm going to pull that in. Now, by doing that, what I just did is I just connected to my sales log table in Synapse. And in my sales log table, I can preview that, and I can see that I have a bunch of raw data here. It's pretty raw. It's pretty denormalized. You can see my product info. I got key value pairs, and you can see that I have these dot operators. I can actually do transformations in place on my raw data without having to do any data engineering. I can also create new columns of data. Like, for example, I'll create a sales tax, and I can create a formula using my data in Synapse. And I can write any formula that Synapse will support. I just did a simple sales tax calculation. And by doing that, I now have my sales tax column, which you see here, which is part of my data set. So now if you look back here, I have my calculated sales tax, and now I can use that in my virtual cube without having to do any kind of ETL. So the way I use it, I just drop it into my measures pane. I decide what folder it's going to go into. And if I look at my preview screen, I now have my first metric. It's in sales metrics folder. It's called sales tax. So let's keep going. Let's add a couple more. Let's add order quantity, and I'll do that. Let's add sales amount, and I'll do that. I'll add it to that folder. So there's my metrics. What about dimensions? Well, here's where things get really interesting. So one of the values of a semantic layer is our reusable dimensions, of course, our conformed dimensions. With @scale, we have this concept of a library, both for data sets and dimensions. So now I can just pull onto my particular model, I can pull on some dimensions like my customer dimension and my product dimension, and of course, my date dimension. Now, these are all dimensions that have been defined just like I just did with sales log. So let's look at customer dimension for a second by drilling into that. I'm going to double click it. So now what you see in my customer dimension is you see it is itself its own canvas and has its own model, starting with dim customer as a data set. You can see it's joined into a gender dimension and a geography dimension. So let's drill into that geography dimension. Well, there's my geography dimension. It's made up of multiple tables: state, city, postal code, and country. And it's all encapsulated very nicely into this one object. So how do I use that object? I can just connect it up to my facts. So I'll take my customer key and do that, and then watch what happens. it just inherited that whole structure. So I get all my customer information, and then I get my geography rollups all for free, all in a conformed way. I can do the same thing with that product dimension. And there you go. I got my products and my product hierarchy. And then this is even better. I have a pretty complicated time dimension here. You can see there's a retail 445. There's a custom 445 rollups. These typically are really tough to do for retailers. For me to use those, all I need to do is take my order date key, and I can do role play by putting in a prefix for order. Now what just happened? I just inherited all the order dates, and you can see I have now order date hierarchies for all my different hierarchies. And I could do the same thing for ship date just by doing and connecting it up the same way and using ship date for my qualifier. And there you see now I have ship date. So pretty good little virtual cube there. At this point, I want to get busy and I want to do some analysis. So how do we do this? Normally, I'd have to build a cube. We're not going to build a cube. All we're going to do is we're going to publish it. So by publishing our virtual cube, there is no build. Now DataFest is now available for query. So I'm going to open up this DataFest virtual cube that we just created, and I'm going to start with Tableau, and then I'm going to show you how it looks like that same semantic layer in both Power BI and Excel. So now I'm logging into my at-scale instance, and what I'm going to see is what I just created, which is the DataFest virtual cube, along with all my measures and my dimensions. So there's my DataFest 2020, and then you can see there's my metrics. You can see there's my hierarchies. There you go. There's my product line. You can see all my data attributes, and of course there's my hierarchies. So let's go and let's do some live queries now. So I just did a query that against for order quantity, and now I'm going to do a query. I forgot something important against product name. Now, what I didn't tell you is that my product table actually came from Azure Databricks. So let me go back to the model and show you that. So here's my product dimension. You notice that the little icon here is for Azure Synapse, you see here. But if I double click on my product dimension, you can see my product dimension, if I look at that data set, actually came from Azure Databricks. So what I just did by running that query, and you can see there's my result, is I just did a federated query. So the business user had no idea that this product catalog was actually in Databricks Delta Lake. And the rest of the data was in my Synapse warehouse. So it was all very transparent. So let's look at order quantity, and let's look at how my drill downs might work. So here's order date. Let's keep 2008, and let's drill down. You can see that our performance is very snappy. These are all queries that are running against Synapse. So let's do one other thing. So let's go and what happens when we want to make a change? Let me come back to my DataFest virtual cube here. And if you remember what we had, if I looked at my sales log definition, is you remember we had some key value pairs. So you can see in the product info field, we have color, size, weight, etc. So AtScale understands this new data, this nested data, whether it's JSON or XML, or in this case, a simple key value pair. And I can actually materialize those fields by just telling AtScale to what the keys are. So now I have color and style. I can take my color, I can take my style, I can make them part of my virtual cube. All I need to do is to republish that view, like so. I can go back to my Tableau workbook here, and I'll just do a little collapse here, go to a new sheet, and I'm going to hit refresh, tell Tableau to refresh, and watch what happens. There we go. There's my color and style. So I just added it to my virtual cube, That's actually a key value pair, and there's my results without any type of data engineering, without any ETL pipeline. I just unfolded a nested field and made it available for query immediately. So before we go to Excel and Synapse and Power BI to show you the same thing, let me show you what happens on the background. So first of all, let's go to our queries screen in Design Center. Let's look at our Synapse project, and let's look at our DataFest virtual cube. So let's look at those queries. And in these queries, what we're going to do is you can see there's my DataFest queries, and you can see something interesting here. So you can see the optimization and AGS in here and the like. So let's do this. Let's look at only the user queries, and let's sort of replay what we just did. So that first query that we did is that first query, if you remember right, what we did is that this was a query that we captured from Tableau, and this is the query that we sent on to Synapse. So you can see that we sent that query straight to Synapse. The next query that we did was that query that we did let's see, by product. So what did AtScale do? Well, AtScale actually created a query against SQL Data Warehouse, Azure Synapse. There's that query. And it ran a query against Azure Databricks to consolidate that query and deliver the results. Now watch what happens if I go and I refresh that same view again. Here's what you see here. So you see how fast that was. Now watch what happens if I just refresh this. Now you see what happens this time is it says it used AGS. So what AtScale did automatically is it took that same query and it actually generated an aggregate table behind the scenes. And so now this query is running purely from Synapse. So rather than doing a federated query every time, AtScale has gotten smart enough to actually create an aggregate in Synapse, which you see here. It's only 606 rows, and AtScale is going to keep that up to date from this point on. So there you have it. There you have AtScale is actually doing, we call autonomous data engineering behind the scenes to actually make Synapse faster and to make Databricks faster and to blend it all together without the user having to understand where the data was coming from. So what does that semantic layer look like in Excel? So let's take a look at that, and let's look at how do we connect from Excel. So here's the beauty. We look like analysis services to Excel. So what I can do is I can simply go and log in to AtScale here through my analysis services connection in Excel that's built in, and there's my DataFest virtual cube. And so now what I can do is I can go ahead and simply create a pivot table. I'll create a pivot chart in this case. And what I'm going to see here is through that connection is I'm going to see the same exact semantic layer that you just saw in Tableau. So there it is. There's my virtual cube, DataFest 2020. Here's my sales metrics. Remember we had order quantity. Remember we did a query against color. Color was that nested field. There it is. And if I go back to Tableau and look at that nested field, what you see is what you get. Same answer, same performance, because AtScale, in that case, if I come back to my query screen again, and I do a refresh here, what you're going to see is that AtScale this time intercepted an MDX query from Tableau, but it used the same aggregate table that we built prior to leverage that performance, and that's how we delivered that instant performance. When it comes to doing the same with Power BI, the great thing about Power BI is that we have a built-in AtScale connector for Power BI, and that's under the databases and under AtScale cubes, which you're going to see right here. So you just go ahead and you just do a connect. And all you do is the same thing I did with Excel. which is that I just paste in my URL to connect. Of course, I'm not going to do an import. I'm going to do a direct query, which is beautiful because whenever data updates, so will my Power BI desktop or my Power BI reports. You can see now I have all my virtual cubes that you saw previously. And of course, I had my project called Synapse and then DataFest. There we have it. And I just selected my DataFest virtual cube. So that's all it really takes to actually access that same semantic layer. And remember, the governance, we haven't even talked about governance. When it comes to perspectives, when it comes to cell level security, when it comes to policies and policy management, that's all done within the at-scale platform, which means, again, all these different tools are playing by the same rules. So let's go and do that same query so you can see this. The answers are the same. Let's do order quantity. Let's do it, and you can see that's going to run a query. And let's do it by color. And like so, there you have it. The same queries running against the same semantic layer, same answers this time. It's going and coming from the Power BI desktop. So my apologies for not showing you the data science part. It's a snafu on my part. But Daniel,
hey Dave,
Daniel,
I'm on if you want me to. Hey Dave,
awesome.
You want me to?
So yeah, Daniel, I'm going to hand it over to you. We only have a few minutes left because we should end in so you got about 3 minutes. So I'll hand it over to you.
Okay.
Thanks, Daniel.
No worries. All right, so I should be sharing now. Everybody should be able to see my screen. So just to real quickly, since we only have a couple minutes here, just to hit on the same concepts that Dave's been hitting on, is that, you know, when you define your semantic layer from the business intelligence perspective, is that you can consume that across your different BI tools, and you can ensure that you're going to have governance around those business constructs. Well, the same thing applies to data science. And so Dave showed an example earlier of kind of the fence pole, someone getting the values wrong. But, you know, imagine a complicated sales tax or a complicated calculated measure. If you have every data scientist redefining those semantics within their notebooks, chances are, you know, you're kind of feeding into that 80% time to transform and clean up the data. If you're able to consume that governed semantic model, then you can skip a lot of those steps of like trying to rationalize timestamps, worrying about imputation of the null values and things like that. That's all taken care of by at scale. And part of that goes back to what Dave was showing you around the simplicity of the queries. So for example, I have a Python notebook up right now. I am consuming that same model that Dave was showing you through Power BI, Tableau, and Excel. Just to show you the query that I'm using to actually populate this notebook. It's very straightforward query, but this is actually pulling data from not only Azure Databricks, but it's also pulling from Synapse, all in one single statement here. If I was to write this query, if I had to join that data together, I'd be writing a very complex query. And then I'd be doing joins across the different dimensions. I'd be handling unrelated dimensions. I'd be figuring out, what do I do with nulls? So do I do a left join, a right join? With that scale, since you have a really simplistic kind of flattened model that you look at, the queries are really straightforward. I don't have to worry about, am I going to multiple places to get that data? Am I joining the data correctly? Am I handling nulls correctly? I'm able to immediately consume that model and then basically start to do my same type of feature engineering analysis that BI users are using for their different BI tools. And so here I'm doing feature analysis to do basically predict cost of sales. And so I'm looking at sales across geo. I'm looking at sales, across different regions. I'm looking at sales across different products. Then ultimately what I'm doing is I'm out in the front line. So I'm also finding new data assets and just pulling them directly into my notebook. And as I do that, I'm then writing those data assets back into Databricks. In this particular case, it could be Synapse or, either one of those two platforms. In this particular case, I just uploaded a CSV file directly into Azure Databricks. And then basically turn that into a table. And now that table, I don't know if we'll have time, but it's very easy for Dave then in the semantic model just to pull this right back in, connect it up with the product key. And now we have a whole nother dimensionality, so category within your features for both your BI users and your data scientists to use downstream. And so it kind of completes the whole loop. So the semantic model applies not only to descriptive analytics, with your BI tools, but it also applies to predictive analytics. So instead of spending a bunch of time trying to write complex queries and join data and figure out how to do it nulls and rationalize timestamps, simply pull the semantic model out, do your feature engineering, train your model, and make your prediction. So I know we're right up against the clock, so I'll stop sharing there.
Thanks, Daniel. That's awesome. So that really sort of completes the presentation. So we can open it up for some questions if you like. We have a few minutes to transition, so I'll give it back to the proctor here to decide what we have time for.
Sure. Do we have any Q&A out in the audience? If not, I'm going to stop the recording and release you on to your next track. Oh, we got a question. You might want to open your question box open because it's a little bit longer one day. Great product, amazing demo. I have 3 questions, so I'll just throw them at you. How does Click connect to at-scale cube? Can you talk a little bit about security and then pricing compared to Azure Analysis Services?
Okay, great. So so the first one, Click connects. You can connect direct with Click. So you can connect. So we do support a direct connect with Click, and so we support that. When it comes to what was the second one? Sorry, second question. Second question
was, can you talk a little bit about security?
Security, yes. So we have the concept of let's see if I can show it to you really quickly here. We have a concept of, we call it a security dimension, and it's how we actually do let's see if I have it in here. I don't have it in here. It's actually how we do cell level security. So there's three different levels. First of all, we do delegated authorization. So the same user who's logged in to AtScale will be the query user on your backend, Synapse or etc. We also have cell level security, which is done through what we call a security dimension, and then we also have the concept of perspectives, where we can actually create different views of your data depending on what people want to see. And then the third question was pricing and compared to SSAS. Because SSAS, I guess I would say it'd be less expensive for the amount of data that you get with AtScale. So we're not pricing you based on the amount of memory like SSAS, Azure SSAS would. So the license is not based on that. So from a TCO perspective, it's going to be very attractive. Any other questions?
Can we do scripting via PowerShell or REST?
We definitely have a REST interface. So, and you can also, we act as we have a JDBC and ODBC interface, so you can use your own drivers with that. So I can actually connect straight to AtScale. I was just doing that with my tool DB Visualizer. So just like Daniel showed you, you can talk to us with SQL. You can talk to us with XMLA and MDX, or you can talk to us through REST, and all those are scriptable, of course.
All right. Just a comment on a great job. Thank you very much.
Well, thank you so much, everybody, for joining and listening in. We appreciate it.
Thanks, everybody. I'm going to stop recording. Thanks, Dave. Appreciate it.
Bye-bye. Thanks.
Bye-bye. Sure.